Good morning, everyone. How are we doing today? Well, welcome to Too Many Security Tools. Ash has entered the chat. My name is Jerry Jones IV. I work at AWS as a security consultant. Been around for a while, 8 years in the federal space, but more importantly, love snowboarding. I game all the time, Xbox. This is my colleague, Pujita.
Hi everyone, my name is Pujita. I'm a security delivery consultant at AWS as well. Outside of that, I've been in the risk and compliance and the IAM space for like a few years. Outside of work, I enjoy traveling, fashion, if you couldn't tell, and coffee.
Plenty of coffee this morning. So what do we have planned for today? Well, it's a short, brief, but pretty fun agenda today. We're going to talk about why security scanning is actually very difficult in enterprise environments, developing all kinds of technology, AI. It is not very easy to do. And so we're going to talk about the star of today's talk, Ash. Exactly what it is, why it's pretty amazing, the built-in tools, there's a ton of them, self-contained, self-packaged. It's pretty intuitive to use. We will see soon because we actually have a live demo. We have an actual 3-tier application mock that we can use to actually see how this thing works, how we would do it in the actual space, and why it can be really problematic and what problems Ash actually solves. And we can see the results, like live vulnerabilities in front of everyone. We can take a look at them and see if you're paying attention closely. Maybe you can spot them before I point them out to everyone. Bonus points if you can. Of course, takeaways, key points, and all that fun stuff. So let's get into it. So the actual problem, right? So imagine this scenario for the young folks out here, for the experienced folks, brand new to an organization, and you are being asked to assess the security for a brand new application's 3-tiered cloud native application. Cool, fun facts about the application itself, the repo has never been scanned. It's been deploying for years and years, and it's never been scanned once. That's a red flag. The app is written in multiple codes and multiple languages, IAC, all kinds of templates that you are kind of familiar with, not really familiar with. You've heard of it before. And the security review is tomorrow morning, 8 a.m., and you're the first one on the job. Your boss is going to be there, the CTO is going to be there, the CISO is going to be there, your mom's going to be there. It's a lot. It's a lot to handle in your first day on the job. The reality is that this is actually not uncommon. This happens all the time. And so the problem is that developers, app devs, backend engineers, they want to move fast. The business moves fast. The organization wants to move fast and market and all that jazz. Security reviews, entirely a second thought. We will get to it if we can. Sometimes, actually never, which is why you hear so much about security breaches that happen all the time. Equifax, it happens. So the vulnerability scans, it's going to have to happen across multiple layers from the backend, front end, middle tier, codependencies, the infrastructure. Throughout all of these areas, vulnerabilities can lie and wait for someone else to find them, and then all of a sudden you end up on the news, which is a problem. Problem being, there is no single security scanner that can handle all of these, to find everything. And managing multiple individual scanning tools, it's problematic to keep them up to date, to install them. That is a lot to handle. And manual security reviews don't necessarily scale very well. So then you find the findings too late, maybe after the deployment and it's live and you see it on your phone, your website, maybe after the breach happens, so data breach happens, and then maybe your organization is on fire and everyone has a SEV 2 and everyone's getting called at 5 a.m. in the morning. It happens. So that is a problem. So what is Ash?
Okay, so imagine like if you had multiple scanners and they were all scanning your repo, it probably sounds too good to be true. But that's probably what Ash does. You don't have to run multiple scanners separately in your code. Instead of, if you have a security review due tomorrow, So this is where ASH comes in. ASH stands for Automated Security Helper, and it's an open source tool from AWS Labs. A lot of people from AWS have contributed to it. So you basically run one command, and ASH figures out whatever scanners need to be run depending on what's in your code and what's not. It scans the code, the infrastructure as code, dependencies, whatever, you name it. And the best part is you can run it locally or in a CI/CD pipeline. And you would have to, like, you don't need an AWS account, you don't need any of that. You can just run like a single command, clone your repo, and go from there. And the outputs are in separate reports, like there's a CSV file, an HTML, so if you need different formats, you can choose the report whichever you want to look at and look at your findings from there. So this is what all the scanners that ASH consists of. There's, for Python, you have Bandit for security anti-patterns and Semgrep for more advanced code analysis. And for secrets, there's detect secrets. It catches all the hard-coded API keys, passwords, tokens. For infrastructure, which is a lot of IACs, what Jerry and I work with, Checkov handles CloudFormation, Terraform, and then we have CFN NAG, which is CloudFormation specific, as well as CDK NAG, which covers all the CDK constructs. For dependencies, since like there's so many libraries and everything that we are looking at within our code, there's Grype that scans your requirement files and logs files against the CVE databases. Each one covers like a different blind spot, and all of them kind of overlap with each other as well, which kind of equals to defense in depth, and see making sure that your code's secure before you actually push it. And this is how ASH actually works. So whenever you push a commit, it's part of one of the build steps, and it runs towards your pipeline. And it runs the 7 scanners for the most part in parallel. And depending on what it finds, it usually says you pass with caution, or you fail as a step in your pipeline. So if you're pass, you're good to go. Pass with caution, you probably have some medium or low critical, like not as critical findings. And then if it's a fail, then you probably have a lot of critical or like highly rated findings. Okay, now Jerry can go right into the demo, which is the fun part.
I will keep the mic on then. So this is not going to be strictly a theory talk. Actually, we're going to be looking at some live code here and a hypothetical 3-tiered application. So let's see what we have for you. So this is actually the repo, and we're working on getting this thing publicly accessible so you can actually download this thing and actually run everything that you're going to see today right on your laptop, not on your phone, unfortunately. But here is the scenario. This is perfect picks. It works kind of like a Tinder a little bit, where you have a basic 3-tier application. Let's call it a web server. Here, we'll use a little bit of AWS terminology because we work at AWS, but this is very synonymous for things that you are likely very familiar with. So we have a web server, right? Someone has to log in, access your web page, access your application somehow. Goes to the public internet, cool. They hit your web tier. This is where, in this scenario, you upload cat photos to your favorite social pics app, cool. What else can you do? We'll have a Lambda, a compute piece of this 3-tier application. So maybe you want to send thumbnails to your friends, and you want to send them some sweet pics that you just saw, but you want to use a thumbnail. This will resize that image from your normal large high-def image to something that's more appropriate for smaller devices like your mobile devices, et cetera, et cetera. And you will use S3 for the storage device. Cool. It's the basic scenario. That's what we're working with. Their structure is a little bit, actually, we can actually just dive right into what it actually looks like. And thankfully, this is showing up, which is fantastic. Make this a little bit easier to see. If you came for some code, you're finally getting it. But this is a YAML file. This is what it looks like when you are deploying code on AWS's infrastructure. So we would define things like the web tier, which is where we're going to define our EC2, which is our servers. And so we're going to open them up. We have the firewalls for everyone to hit. We'll give it a public IP. Click there. It'll serve you up right here. The storage tier is also defined here, and a number of properties that allow certain permissions to be made. It gives the processing layer, the Lambda function, a permissions to access your storage, access your photos, and do the things that need to be done, which is resizing. So let's see the actual stack itself. This is what we use to define the structure of the resources that we are deploying. So we have a VPC, which is more like a networking piece, okay, and the web tier, which is for the instance where it's going to live, what the networking is, the firewall rules, and et cetera, et cetera. That is where this is going to live, and the bucket, which is where the primary storage is. Now, maybe y'all have tuned into the news recently about public API keys, access keys that are stored in the public space, and then some research scientists are going to poking around and they find API keys that are just sitting there. Well, if you have looked at this code a bit, we have created the same error. Right now, this block public policy is actually live. If I deployed this right now, everyone could just log in and actually see the same stuff. And that is a problem. We have all kinds of permissions issues also. Right now, the Lambda can do anything. It can access the storage for S3, sure, but it can also create new users. It can create new EC2 instances and create crypto mining servers to mine crypto for an untold amount of time. This is a problem, but maybe you didn't catch that. And here's the actual Lambda piece itself. It's written in Python to handle the actual resizing of the images and puts the object in the right spot. Okay, but we have a couple of issues here too. Pickle is a known vulnerable library that we are using. That's not great. Subprocess, that is not great. We have some issues up top too. Well, we have our API keys and our super secret access to our database sitting in broad daylight. So if you happen to come across this, you will just be able to access this. Obviously, this is a problem, including our super secret system guide video that, well, we can take a look and we can see what this is all about. Well, that's not what's supposed to be there anyway. So, problem is we have some keys. We have secrets that are available in plain text. What we would normally do at this point as a developer. Make sure that we're in the right demo or the right space here. So Bandit is what my colleague Brigitte already spoke about. It's a pretty great tool. And we would typically install that. We'd have that whitelisted and install it to our local desktop as we are developing. We would use this to scan certain things. Specifically, we'll use it to scan the Lambda service specifically for any issues that it might find. And what it found immediately is we are open to SQL injection right off the bat, immediately. Well, that's pretty good. It found a couple of other things as well. Oh, there's the pickle I spoke about earlier, that popped up. Issues. Problem is, Bandit is a single-use tool. You have to install it, maintain it, and know how to use it and put the right commands. That's a lot to handle. What else can we find? Checkov is a infrastructure as code analyzer, which is great. Again, you gotta install it, manage it, learn how to use it, maintain it, and then run it. That is a ton. Let's look at that CloudFormation template that we use to deploy all of our AWS resources and see if it found anything that is problematic. And of course, it did. One piece, the Lambda role has too many permissions. It can spin up EC2 instances and do the crypto mining thing or host pirated websites and all kinds of stuff that we just don't want that to happen. Well, it found a whole host of other ones. Take a look if you'd like. Problem being, it found a ton. But to manage each one of these tools, and there's a ton of tools out there that we can use, to manage each one is really effortful, and we want to make security easy. So what is Ash? Ash is a compilation of many tools wrapped into one for your use. Let's see what happens. Because rather than scanning individual files, each one by one, we can use Ash. Thankfully, I've already downloaded Ash, but if you can immediately see, Ash 1 looks a lot better. It's a lot more intuitive to actually see what's going on. As we mentioned before, there is, I think, 10 tools that are wrapped right into the package compiler itself that actually runs all of these tools concurrently. I've used one line of code with one package to maintain, and 10 tools run concurrently, and we actually already have 6 done, I think. It's not foolproof, but it makes catching easy to solve things easier. Last one is Semgrep, as that will wrap up. We will be able to see what the output is, because certainly Bandit found some stuff, Checkov found some stuff. I want to know conclusively what else is there that can be easily found. The nice thing is that it makes a nice dashboard, I'll call it a summary of all the issues that we found. So, for those who are keen of the eye, Bandit found some stuff. Cool. Checkov found some stuff also. 14 criticals, that's not great. But what else did it find? We didn't even talk about CDK nag, which is useful for checking your IAC templates to see what happened there. And detect secrets, right? That super secret video file that we loaded up, well, it found that too. The database secrets as well. It's found quite a few things, and even Semgrep, one that we didn't have time to talk about today. We'll love to get into it next time, but a useful tool, it found more things still. Great. Well, what do we do with this information? How do we view it? I don't want to show my manager my terminal. That's probably not great, but instead, the nice thing is that Ash outputs this information in all kinds of formats. One, it makes it in an HTML file, really easy to print, make a file, give it to your boss. It's fantastic. Here are all your issues categorized by finding and security tool. Let's see what that actually looks like if I can get to my actual file. So this is what the one version, and there's many versions that you can use, that actually shows you what this scanner picked up. So it gives you the date, gives you the time, gives you the version, and most importantly, it gives you the findings. In totality, it's probably over 35 in this one hypothetical. Believe me, Enterprise will find many, many, many more. It's nice because it shows you by scanner what it picked up, by severity, what it picked up, by type, what it picked up, and even gives you hotspots. Developer time is very expensive, and also there's not a lot of them. So you can focus and triage what you want to focus on to get the biggest impact. That being this CloudFormation template has 19 findings in totality. Maybe we should spend some time there to try to limit our threatscape. And it actually also even included the hard-coded password, which was that HTML or HTTP URL for the YouTube, but included our hard-coded password and the other hard-coded password. I actually forgot that was in there. The pickle piece, the weak MD5 hash, possible security injection piece. Point is that this was easier for me. I ran one line of code. It worked for a little bit. There are a ton more tools that are available in a container. If you want to run that, we can get into that. The point is that you can manage 13 tools on your own, have them whitelisted, maintain the versions, and learn how to use them and write the command lines. And that's a ton of effort that I personally don't want to do. I want to learn one. And Ash really is really powerful tool, a really powerful tool to have all of that wrapped into one single place. Jumping back.
Okay, that was a lot. But you guys saw what Ash does, and so you used Ash. Now you know you found vulnerabilities. The HTML report was easy to read. You went in and fixed everything, and you mission accomplished. Like your security review that was due at 8 a.m. tomorrow, you were able to get it done right on time. I think Ash just makes it so much easier for you to run like a security review, like a DSR. I feel like everything we do, we run so many DSRs on the daily, and Ash has made our lives so much easier in this past, like ever since we've started using it, probably the past year. Security. Yeah. Okay, so some of the key takeaways from this. Shift left, the earlier you catch these things, the cheaper and easier it is to fix. Ash lets you scan before you even commit your code. That's the best thing. Second, no single tool is ever going to be enough. You need to run multiple scanners for different types of things that you need to scan in your code, and make sure that you're catching vulnerabilities before the code is out in production. And multi-scanning security with one command that's security at your fingertips, and you have to deploy nothing to run this, just one command. So as you saw, just to reiterate, the infrastructure was flagged by Checkov, CFNNAG, and CDKNAG, and the hard-coded secrets were caught by Bandit as well as detect secrets. So there were multiple scanners catching the same thing, so it kind of overlaps for you to double-check your vulnerabilities and make sure you're remediating them before your code gets pushed. And last but not the least, you saw that there were different types of reports that were generated. The HTML was visual, shareable, like if you just want to do code reviews for other peers, that's what helps you. And then the CSV, I feel like that's what I look at a lot. It's spreadsheet friendly for just tracking and triaging everything on as we go. That's about it.
And so the Ash is open source. Like y'all can download this right now, take a look at it, poke around with it. It's updated, maintained daily. It's done or maintained by our colleagues over at AWS Labs. They handle everything there. It works with Python and JavaScript and all kinds of languages that you probably use every day or will use at some point in your career. And if you want to use other tools too, it has plugins. It's very customizable. If you've got some tools that you like a lot and maybe you like the most, feel free to plug it right in and have that maintain it for you. The best part is it's open source. Like if you want to contribute to make this thing a little bit better, they do they approve pull requests every day. So we did not make Ash as much as I would love to have claimed that. We have not. So the open source project is there. It's under the Apache 2 license, but point is that, hey, if you have some time and you are wondering about what security tools do we use in everyday life, Ash is the answer, and you can feel free to take a look at it today. But aside from that, that is what we have for you today. Do you have any questions around how we use it and what it's for and anything of that nature? Yes. So I'll repeat the question for those who didn't hear it. How does Ash handle false positives? So the nice thing for every security professional here is that while it's really good at detecting secrets and detects secrets in that specific instance, it is focusing on certain keywords that we use, like API keys, access keys, passwords, DB, like it keys in on those words. And maybe you just have a nomenclature for that variable that it actually isn't. It's maybe hashed or it's maybe masked in some way. How does it handle it? Unfortunately, it won't. It will still find that and it'll put it in the report for you to then validate. It's a great tool for scanning and determining what are the easy to find issues. But we as security professionals still must validate what's going on with it. And so we will look at each finding and determine in the code, well, is this a real finding? Yes for the pickle, yes for the overly permissive Lambda function. How about this password? It's a bad name because I called it password, but is it a real finding? No. You can additionally work within the tool itself to add a suppression, which says, hey, we're good to go and no risk there. But thank you for the question. That is fantastic. Any other questions? Yes.
Might this be something that AWS actually just puts on the dashboard instead of having to go compile it and run it, where it's like, hey, you've got an AWS container, run the Ash tool against it, and it works out?
Can we make it easier? I love that question, and the answer is yes. Yes, we can. Oh my God. If you have to have this in your individual developer laptop, it's a great tool, but ideally you do want to make it easier to do. Can we put it in a dashboard? Can we have this thing running into the code every single time? Yes, we can. You will put it in a CI/CD pipeline. You can containerize this whole thing and have it scan against your entire code application, and then put it in a dashboard that puts all those findings there. You will still have to validate it against your own expertise to determine if it's an actual finding or not, but you can have it run automatically right in the pipeline, scan against it every single time, and have the dashboard available. Great use case for making this much even easier to use. Now, so we got 2 more minutes. Anyone else have any quick questions that I can answer? Yes. Say it again. Detect Secrets is fairly lightweight. You saw it run against 200 lines of code with multiple IACs. I'm sorry, yes. But the question was, how does Detect Secrets work against Troublehall? And the way that it is, install them both. Maybe one catches one that the other doesn't. The nice thing is it's open source. Use them both. You probably would be better off for it. That said, it is lightweight. It won't hurt your performance all that much. But that said, we are out of time. We've got to get going. But thank you all for coming. It was great to have everyone here. You all take it easy.